All right, so we're going to be looking at our SN1 reactions, all right? So our unimolecular nucleophilic substitutions. Now, this is a bit different from the SN2. So it actually has two general steps. Technically it has more steps, one called like full dilution and etc. But in unit 1 we look at generally unit 2 we look at generally two steps, right? Now, it's not concerted. It doesn't really occur within our primary halogen alkenes that much. So, well, that much is said. So it really occurs in our tertiary halogen alkenes, and it can occur in secondary, right? But the syllabus asks us to really focus on the tertiary. So let's have a look at that. Let's draw a general tertiary halogen alkene. All right. So I'll have an R group. So in order to save time of just drawing a bunch of methyl groups or something like that, just gonna draw an R group. So we have this here. So we have multiple R groups here, right? And it's attached to, let's use a halogen, right? Let's use bromine as a halogen, right? Now, in this case, right, we're gonna have some amount of bond polarity, right? But in this first step, let's write step 1. In this first step, it's gonna be different from SN2 in that we actually are going to form a carbocation intermediate, and that is because it's going to form a tertiary carbocation and it's going to be really stable. So it wouldn't mind, you can think of it like that, this species wouldn't mind forming an intermediate. So we're going to have the heterolytic cleavage of this bond because we know that bromine is more electronegative than the carbon, all right? And we're going to have the creation of that tertiary carbocation, all right? We're gonna have a creation of that tertiary carbocation. Okay, so let's just draw this out. Everything there should be fine. All right, so we have this there, no problem at all. So the first step is the formation of our carbocation. It's showing the leaving group, it's showing the heterolytic cleavage, right, of that carbon halogen bond there. All right, and let's use hydroxide as our nucleophile. All right, so if we were now to look at step 2 now, all right, we have this intermediate already here. All right, have this intermediate already here, and we're going to have an attack from a nucleophile like our hydroxyl group, right, or a hydroxide ion, right, and it's going to be attacking in just general direction, right? It won't attack from this direction specifically because of steric hindrance, right? It's going to be blocked. Let me fix that R group there. It's going to be blocked. Right, so we're going to have a backside attack, right, similar to what we looked at before. And we're going to have inversion of the molecule as well, right? So what we're going to have as the result here would be something like this, right? Something like this. All right, so that would be our product, all right, due to stereochemical inversion. So we remember what inversion really looked at on this other molecule. So let me fix that real quick. The screen just went down. All right, so on this side of the molecule, right, the R groups are located on the left hand side, and on this molecule is located on the right hand side. So you know we have an inversion there. All right, so step 2 is showing the addition of the nucleophile. All right, so we have that there. So that's generally the process there. Yeah, so that's generally the SN1. So step 1 is gonna be the heterolytic cleavage of the carbon halogen bond to form the carbocation intermediate, and this is the slow step, or the rate determining step. all right? And then here now we're gonna have the addition of our nucleophile here, which is fast. All right, so we have that there. Okay, it really only occurs in tertiary halogen alkanes for Unit 2 chemistry, but it occurs in secondary as well. All right, and for the SN2, right, SN2 only happens with our primary halogen alkanes and in Unit 2, and we can look at that in secondary as well. It can also occur in secondary. So secondary halogen alkanes can undergo SN1, SN2. Primary can only undergo SN2. Tertiary can only undergo SN1. All right, so that's really it there.